Well, hello and welcome YouTube. Mr. Robbins back here with yet another brand new exciting video, all math-based of course, and as always it is an honor and a privilege to be serving you here today as it is every day here in my virtual classroom. Let's step on inside and let's look at more on polynomials. If you last joined me, I was adding and subtracting polynomials, basically combining like terms, and now we're going to be looking at polynomials in a different state where we multiply by them. Specifically for now, a monomial with another polynomial, perhaps a monomial or a binomial or trinomial or quadrinomial, some other set, but a monomial with it, which is kind of nice because if you've used the distributive property in such a way, then you're probably a little bit familiar with that. We're going to learn a single exponential property during this one as we do it. And not much in combining like terms. I don't think there is any combining like terms here, but if you understand this one, that's going to be good because it leads into multiplying binomials together or any polynomials with each other in the special cases that come in my next two videos. So I'm going to do a practice set here. I believe it's, let's look. There are 9 problems on this page here, and then after that there are 16. So 16 total problems that we're going to be looking at here. And in order to make sense of them, I'm going to do one thing at a time. For starters, as we're multiplying, what I want you to recall is that when you have something like 3x, and I'm not doing this example right now, but when you have something like 3x, 3x means 3 times x. And this is important because these two already are multiplying. So you want to know that those are multiplying in and of themselves and will be multiplying with something else as well. We're not combining like terms, but we are fusing items that are similar, such as numbers with numbers will multiply and variables with variables will multiply. So just make sure that you understand that 3x does mean 3 times x when it comes to multiplication, because I will be doing some things to start off with to make sure you make sense of it as far as reordering items, putting numbers next to each other and such. You know that you can reorder things. A times b equals b times a. You can reorder things in a product. It's called the commutative property of multiplication, and you will still get the same result. So in order to do a problem like number 1 here, as we start this, we have 3x times 2. Oh, I'm sorry, there's one more thing I want to mention. It's the bigger thing that's actually much more important with this, is multiplying variables. When you have something like x squared to the second power, this exponent means how many times or how many x's are multiplying with each other. X squared means x times x. So those are 2 x's multiplied with each other. Want to make sure you know that. And so x to the 5th, for example, would be x times x times x times x times x. Now I'm not going to get too big in that, but I want to make sure that you know that the exponent means how many x's are multiplying together. The other important part, the big property that we need to know for this, besides all, this is just knowledge of remembrance, but the property that we're going to work with here, what if I did x squared times x to the 5th like this? What would the result be? Well, I want you to think about what happens when you have 2 x's multiplied here, 5 x's multiplied here, and you're going to multiply them. If I have 2 x's multiplied, 5 x's multiplied, and I'm going to multiply that result, the answer is the simplification of how many x's are multiplying together. The answer is 7 of them. How are we getting 7? Well, without writing all this out, guys, it's shorthand 2 plus 5. That's right. When you multiply variables of the same base, you keep the base and you will add the exponents. So our property that I'm going to write down looks like this. X to the a power times x to the b power. If you have the same variable, you keep the base and you add the exponents because that's what exponents are. They describe how many of that variable are multiplying together with each other. So you count them, you add them together, and that's what that is. Okay, let's go ahead and get started. This will go a little quickly after you start to recognize them. 1 through 8 is monomial times monomial on all of these things. That should be pretty nice, and I'll smooth it out more as I go, show you some less steps, because you can do these really in one step if you know what you're doing with it. But I'll go slowly to begin with. Number 1, 3x times 2x squared. Now remember, what this does mean. What this does mean is you could rewrite this if you wanted to as 3 times x times 2 times x. X squared is x times x. If you really want to split it up as full as you possibly could, guys, this is what we're looking at. 3 times x times 2 times x times x. Now as a rewrite of that, I'm going to put 3 times 2 next to each other. 3 times 2 times x times x times x like that. And now we can really simplify things in such a way that I can multiply numbers, 3 times 2, and I get 6. And I can multiply these 3 x's together, and I get x times x is x cubed. And that gives me 6x cubed. That is a really long way of going about the problem, but this is giving you the fanciful idea of what multiplies with what and how. And I won't be doing that each time. For the most part, I really won't be. I'll do it again on number 2, but I won't expand my x's this time. This time I want to use this property, and then we'll go back and make sure that this property made sense with it. Okay, number 2. 19 x to the 5th times 8x cubed. That is 19 times x to the 5th times 8 times x cubed. If I wanted to rewrite that, I could write it as 19, as 19 times 8 times x to the 5th times x cubed. Now 19 times 8 161 is 152. It's 152. And x to the 5th times x cubed, what I'm going to do is I'm going to add the 5 with the 3. The result, we're not multiplying the exponents. The exponents state how many x's are multiplying. So that becomes 152x to the 8th power, like that. So again, you're just cleaning that up. Now, why was this one x cubed when I did x times x squared? I have x, right? That was x times x squared. Because x is to the first power, and the x squared obviously is to the second power, that becomes 1 plus 2, which is 3. There's that result. Okay, number 3. 6x to the 7th times 3x cubed. This is 6 times 3 times x to the 7th times x cubed to put things next to each other there. 6 times 3 is 18. And 7 plus 3 is 10. Once again, the exponents add when you have the same variable. And the last one, maybe you can start to get into this a little more mentally here. It looks a lot like number 1, only now it's an x squared and an x cubed. So on number 4 here, I will be doing 3 times 2 and I'll be getting 6. And I will be doing x squared times x cubed. That's x to the 2 plus 3 power. That is x to the 5th. So you can see how you can definitely go without possibly really showing work, at least on the monomial times monomial aspect. It's very possible to do. Now, I don't know if they're trying to confuse you here, guys, but the coefficients, we multiply 3 times 2 because that's actually what they're doing. And remember, we're not multiplying the 2 and the 3, guys. We're multiplying x squared with x cubed, which results in the exponents adding. So although 3 times 2 is 6, 2 plus 3 here was 5, and that's that result. All right, jumping to number 5. Now we're going to have multiple variables here. And if you could already tell, guys, this wasn't about combining like terms or not combining like terms. This is an addition. We're not just keeping the variables and adding the coefficients. We're doing something a little bit different here. But we are going to multiply numbers with numbers, x's with x's, and y's with y's. If I did a rewrite of this one right here, it'd be 7 times 3 times x squared times y cubed. Just kind of putting all together the idea of what's going to go. It's not like terms, so to speak, but these things do associate with one another in a way that you multiply them. Because one more time, the exponent itself is kind of just mentioning how many of that number is multiplying, or that variable. 7 times 3 is 21. X times x squared is x cubed, because remember that's x to the first. And y to the first times y cubed. 1 plus 3 is 4. That becomes y to the 4th power. One more time, and I really just want to say this one more time, I'm adding the exponents there when I multiply at the same base. All right, a little bit larger of a monomial here. The next 3 are monomials. And, like I said, this really does speed up once you start to learn it more. Let's do 6 times 5. 6 times 5, that's 30. Let's do x times x, that's x squared. We should know that straight up, right? That's kind of how the property works to begin with. X times x is x squared. So x times x squared there. Y times y cubed is y to the 4th. We just saw that on this one. And then there's a z to the 4th. That's, it doesn't multiply with another z. I guess you could say it multiplies with 1, but there's a z to the 4th that's still there within it. Now, we've done monomial so far every time. Monomial times monomial, and you've seen that the result has been a monomial. It's a single term, just like it was a one term times one term. When we see monomials multiply with binomials, we'll see a different story, especially if nothing would combine. Okay, 7 and 8, they should go pretty fast now that we've seen several of these. Let's jump to the green. 8 times 4 is 32. X, no other x's here, but that one x alone. And y cubed times y to the 4th is y to the 7th. And there is a z squared left over. Once again, guys, I don't know how much work really needs to be shown once you recognize the stuff. All the expanding stuff was just me teaching it. And maybe at this point you're getting it. Maybe you can go without the work. Last monomial times monomial, we have 11 times, well, it's a 1, but the 11 stays coefficient-wise. X times x cubed is x to the 4th. Y times y squared is y cubed. And again, I don't really know how much more work to show once I do that. This starts to get kind of fast once you really recognize what you're doing, and that's the good news. Okay, now number 9. Number 9 is a binomial times a monomial. So we do have that instance there, and these can't combine. They're not like terms, x squared plus x, they don't become a monomial there. So we are going to multiply the x cubed in with the x and x squared. Now, if you need to know a property for here, this is the distributive property. when you multiply something with a sum or difference here inside of a quantity, you multiply the a with the b and the a with the c here, and you get a result that's, if this was a monomial times a binomial, the result's a binomial with the product jumped in like that. So when we do number 9 here, and it's kind of weird because x cubed is on the right side of it. If personally, preferably, I'd love the x cubed to be on this side. X cubed times x squared plus x. It's neither here nor there. But the point is, when I distribute here, x cubed is going to multiply with x squared, and x cubed is going to multiply with x. So let me just write that setup to begin with. X cubed times x squared would look like that right there. And then plus, we got x cubed times x right there. So let's simplify that and clean that up. X cubed times x squared, we add the exponents, we get x to the 5th. And x cubed times x to the 1st would be x to the 4th. And you know, if I couldn't combine anything before here, if I couldn't combine this binomial, then I won't be able to combine this binomial either, right? We're not turning this into x to the 9th or something. It's not x to the 5th times x to the 4th where we would get that. Just these don't combine. There it is. And it's in standard form, by the way. I'm going to make sure that I write them in standard form when I can, when I have a binomial. Okay. Next page and 7 more problems here. You can see they get a little more expansive over time, but I have another binomial times a monomial. And once again, I'm going to kind of write it this way. Let's do x to the 4th times these two things here. Now, x to the 4th times x cubed, if I leave out that in between step, I will get x to the 7th. And 2x squared times x to the 4th right there, multiply x squared with x to the 4th, I do get x to the 6th as the exponents to add. Now this is also in standard form. It looks like when they do them, I'm looking at all of them, they all look to already be in standard form. Good on them to do that. And I can even reiterate how it is that they're determining standard form. I don't really know why the monomial's on the back side though. When you see me make these problems for myself, you always see me try and put the monomial in the front. But it's kind of easier to mention that the monomial is multiplying with each term here. Distribution doesn't apply to just times a binomial. You can multiply by as many terms as you like. The x cubed is multiplying by all 3 of these. X cubed times x squared ends up being, hold on, x to the, let me change the color, x to the 5th. X cubed times 2x becomes 2x to the 4th power. And x cubed times 5 becomes 5x cubed. Now, I've seen a lot of mistakes with students in the past in doing these kinds of things here. You have to be careful in multiplying with x. For whatever reason, and I know my students are going to do it, for whatever reason, you do 2x times x cubed. A lot of people kind of negate the x that's there, and you'll just write 2x cubed. Be careful. That's not what that is. It is 2x to the 4th. That x is to the 1st power. If anytime you see a single x and you just need to write that 1 there, and to help you, no one's stopping you. Go ahead and do that. And again, standard form, trinomial there. Quintic trinomial, if you will. All right, number 12, we are now multiplying by a 5-term polynomial. And because these can't combine, this will end up, yes, being 5 terms. And, I don't know what more to say other than do the answers here. X squared times x to the 4th is x to the 6th. X squared times 3x cubed, keep the 3. And x cubed times x squared is x to the 5th. X squared times 2x squared is 2x to the 4th. X squared times 11x, it's not 11x squared, but 11x cubed. And then x squared times 4 is 4x squared. And look at the degrees of these. This was 4, 3, 2, 1, 0. Now it's 6, 5, 4, 3, 2. The degrees shouldn't change as far as their separation. It looks like I was going down by 1 degree on each term here. And that should still happen here. That shouldn't be changing as a result of me just multiplying something here. In fact, they got 2 degrees larger. The degree got 2 larger for each of them because of the x squared there. Okay, number 13, we're going to do a monomial times a trinomial here, only this time with x and y involved. So 4x squared y, let's write this one out. I got 4x squared y multiplying with x cubed. I have 4x squared y multiplying with 2y squared. And I have 4x squared y multiplying with 3xy. There's the distributive step right there. 4 is still hanging out. Let me change the color here. Okay, 4 is still hanging out right here times 1. We get 4. X squared times x cubed is x to the 5th, and there's still a y going. Don't forget about me. And not multiplying with anything else. So there's that one. This one I have a 4 times 2. 4 times 2 is 8. Be careful here. 4 times 2, you're going to say 6 because you're going to think about adding exponents. These aren't exponents. We are multiplying. Don't forget what the end goal is. X squared here. And I do have y times y squared. 1 plus 2 is 3, so y cubed. And then 4 times 3, that's going to give us 12. X squared times x is x cubed. And y times y is y squared. You know, I'm looking, sorry, I spoke slowly because I'm looking at this right now. This actually isn't the most of standard form that I'd state here. I have a different preference in standard form here. And what I'm going to do is I'm going to rewrite the last two terms, because what I see here is this is of degree 5, right? 2 plus 3 is 5. And then this one is also of degree 5 right here. This one, by the way, is of degree 6. There's a tie in degrees of 5 and 5. What's recommended that you do is you rewrite this in the order where if you have a dominant variable such as x is dominating because I chose it to be, because it's alphabetically first before y. If there's a tie in number of degrees, you go with the alphabetically first variable, treat it dominantly, and say which one has the higher degree among those. This is an x cubed. This is an x squared. Doesn't matter that this y is cubed. It just makes the degree 5 in both of these. But I'd rather write this term first because this x is cubed while that x is squared. So I'm going to have 4x to the 5th y plus 12x cubed y squared plus 8x squared y cubed. That's not important unless they require that you write in standard form, and unless someone is letting you know that that's the proper standard form of this. If I go back, are they asking us to write in standard form? Not really. They just say find each product, but it's a good practice to always have. Okay, 3 more problems, guys, and then we're done. We'll be able to, sorry if my audio is clipping here. It looks like I'm at a higher volume than normal. Give me one moment as I try and maybe reduce the volume here, or see what the volume setting's at. Oh, no, my volume's decent. I'm going to stick with it. Okay, 14, 15, 16. 3 more problems. Maybe I can get them close to cracked in by 20-minute mark. So once again, distribute 3xy multiplies with 2x cubed. 3 times 2. I'm trying to do less work and show you that example. 3 times 2 is 6. X cubed times x is x to the 4th. And hey, don't forget the y. And then 3 times this times this, right? These two. 3 times 5 is 15. There's an x that's just left there multiplying with kind of nothing but 1. Y times y is y squared. And these look like it's in standard form. And we're set. 2 more problems. Let me erase those degree marker things there. And let me get my y back, of course. 6xy squared. I don't know if they're getting harder necessarily, but they do have 2 variables. They're just throwing more at you. 6xy squared times x to the 4th. I do have a 6. 6 times 1. X to the 4th times x is x to the 5th. Excuse me. And y squared is left over. That's for the first term. Change colors. Second term, I'm going to have 6 times 3. That's going to be giving me 18. Give me a moment. That's 18. X to the cubed times x to the cubed. X cubed or x to the 3rd times x is x to the 4th. And y times y squared is y cubed. Once again, that's a 1 plus 2 going on. I hope right now I am kind of just doing the problems. I'm going to finish on this last one there. And then next video you'll see is binomial times binomials. A little different story. But you can see I'm really skipping steps and just doing the problems. At this point, that's, I'm kind of expecting you know what to do as I play with them. All right, last one here. 6 times 3, one more time is 18. And I got x times x, which is x squared, and y cubed times y squared, which is y to the 5th power. Now, these are a tie here, once again, in degrees. This is, actually, all of these. This is degree 7, degree 7, degree 7. But when you look at x being the dominant variable as it's alphabetically first here, you see that this x is to the 5th power, this is to the 4th, and this is to the 2nd power. So, all good there. These don't combine as far as like terms or not. And once again, if these combined, then that means they could have combined before, and they couldn't have, so we're good. All right, last one, number 16. Distribute everything that we can. 11, and listen, this becomes a long line of problems here when you have the product, but that's okay. 11x squared y cubed times x to the 4th. That's 11x to the 6th y cubed, the 4 plus 2. Then you have 11x squared y cubed times 3x cubed y squared. 11 times 3 is 33. X squared times x cubed is x to the 5th. Y cubed times y squared is y to the 5th. So far, it's in standard form. Well, no, it's not in standard form. 6 plus 3 is 9. 5 plus 5 is 10. I'm going to make sure to rewrite that thing later. Hold on. I must have messed up. Oh, no, I did. I'm sorry. Wait, no. I'm sorry. X is 6y cubed. I didn't, oh, yeah. Yeah. This is degree 10. I was just looking at the x's only. No, that's only if there's a tie. This isn't a tie. This is degree 10 because it's 5 plus 5 there. Okay, 11 times 4 is 44. X squared times x squared is x to the 4th. Ruh-roh. Y cubed times y is y to the 4th. Here we go. 11 times 8 is 88. X squared times x is x cubed. Y cubed times y is y to the 4th. And lastly, sorry, you can't really see them anymore. 11 times 12 is 132. X squared times x is x cubed. And y cubed is left over. So that would be a final answer. I'm sure that's what they want. If I wrote standard form here, let's look at the degrees now that I have this 5-term polynomial. I have degree 9, 10, so that's going to be probably first here. Degree 8, 7, and looks like 6. So I'm going to rewrite these things here. I'm going to get that one first. This becomes 33 x to the 5th y to the 5th plus 11 x to the 6th y cubed plus 44 x to the 4th y to the 4th plus 88 x cubed y to the 4th plus 132 x cubed y cubed. And that's standard form. Switch the first two terms there. And there we have it. All right, guys, and that will actually be it for this video, okay? That's all I was going over here, multiplying a monomial by these things. You can see they're not necessarily getting more challenging. They can get bigger. We can have an x with a y and things like that. But that's kind of it with that, and that does help us for when we get into the next one. When we multiply a binomial with a binomial, we use something called the FOIL method, and we just understand distribution a little bit more, and there might be some combining like terms in the next one just because of the nature of how the problems work. So that ought to do it for this one, guys. This is Mr. Robinson. Thank you so much for watching, and I'll see you very soon. Take care.